Okay, yeah. Myself, Shankar Lal Dangi, currently pursuing PhD, and we will talk about enhancing oil recovery through suspected dry wettability alteration in Gargzdai field. We will talk about EOR method and which EOR method we use, and we will talk about wettability alteration surfactant and the mechanics, and lastly we will talk about lab test results which we got from the field. Lithuania is a part of Baltic basins, in which we have multiple wells for oil and gas, and majority of oil and gas wells are located in Lithuania or Latvia in Baltic regions. More than 15 wells are drilled in this formation, and first well was drilled in 1990. And then from 2000, oil productions from this formation is decreasing with times. And so we in for this we use EOR method to improve efficiency in these formations. Firstly we collected field data, then we uses SPA screenings, then after SPA screening we uses ML algorithms for further screenings. Then based on SPA scaling and ML evaluations, we choose which method we can use for lab testing. Then we did a lab testing for best candidate. Gargzdai reservoir field is located in western part of Lithuania, which is a part of Cambrian formations. It's a very heterogeneous formation with permeability ranging from 0.01 milliliters to 100 milliliters. Historically, 11 production well was producing with currently recovery from flooding is 27%. Water injection rate was 500 barrels per day per wells, and currently production rate was 200 barrels per day from 4 wells. These are the other properties with porosity ranging from 1 to 12 and API gravity 43.4, oil viscosity 0.63 to 1.44 centipoise. Based on production forecast, most of the well will shut down after 2025. So we urgently need some other method as water flooding is not enough for these formations. So based on the data, we use the SP screen. Based on SP, we did initial screenings for this formation. In situ flooding is not suitable as it's not in the range of temperature and API gravity. Steam flooding is not suitable based on the depth. Nitrogen and few gases are not suitable based on viscosity, and alkaline flooding alone is not suitable based on the API gravity. So we uses Dieslip software. Dieslip Tubes is a cloud-based platform that integrate laboratory data, physics assistance model, and machine learning model to recommend suitable EOR techniques. Based on this method, we can here we did a sensitivity analysis of viscosity with 0.63 to 1.4 cc, and based on the result, we can get that chemical flooding is more suitable compared to other polymer and other immiscible CO2 flooding and other flooding. So based on these two method, we can conclude that for very heterogeneous formations, we can choose chemical and gas floodings. And for based on all these things, we conclude that surfactant based EOR can be a good choice. CO2 flooding can be used, but in these formations, we have a legal barrier to use the CO2. So let's talk about why wettability matters. So in oil wet reservoirs, water injection is insufficient because it's bypass oil, and in oil water wet reservoir we can get a better recovery. But when we have a oil wet reservoir, then we want to change the wettability. So surfactant act as to change the wettability. Wettability depend on contact angles. More than 90-degree contact angles is oil wet, and less than 90 degrees is water wet. So how the surfactant is work? Surfactant molecule absorb on a rock surface and modify the surface energy. They remove polar oil components that are binding the rock surface in oil wet state. Once the oil become water wet, the water can imbibe naturally from into the pore space, mobilize and release trapped oil. So for firstly, we want to check is our reservoir is water weight or oil weights. So we read a amount wettability text based on the result of this negative result of I IAH value indicate the our formation is oil weight. Then we want to confirm with again we want to confirm. Then we use the water droplet test. Here also we can see the our formation is oil weight. Then we did a calcite play test using surfactants, and we can see the oil as oil drops are moving out of the calcite plate. Then we did that same with our reservoir rocks. Then here we treatment with surfactant solution allow water to imbibe into the rocks and displacing oil and releasing to the surface. We can see in different time frames after 1 hour and 2 hours we can get more oils from the same reservoir rocks. Here we see the how the contact angles and IFT changes. He in both the samples to 2.1 and 3.3, the contact angle changes to a 45 and 43, and IFT also changes because of surfactants up to 1.5. And then we see the we tested core flooding also. And from core flooding results, we can see that using the surfactant, we can improve recovery up to 5%. And maybe you think the 5% recovery is very little, but when we see the in actual cases like here, 5% recovery is equivalent to drilling a 2 to 3 new water injection well, and if we increase up to 10%, then it's equivalent to 3 to 4 new water injection wells. So increasing 5% is same as drilling 2 to 3 new water injection wells. We conclude with machine learning and SPA screenings that chemical UR can be used. We also confirm that our formation is water weight, oil weight. Surfactant injections can alter wettability from oil weight to water weight. No, water weight to oil weight, sorry. And we see the changes in wettability and IFT. And this work is supported by Minios Naphtha and Geotransition Energy. Thank you. Have any questions?